So in this tutorial we're going to have a simple introduction to creating CNC programs from within Creo, and the part that we're going to use as an example of something that you may want to machine using CNC machining is our mold half. So you can see I have my cavity half of my mold that I've created. I've added some extra little features in here, such as these air vents, which are very shallow grooves that are machined into the parting surface of the mold. I've also, just as an example, added a through hole in one of the corners here. So these have all been added in the mold creation assembly that we use to actually create this mold. In reality, if you were doing this kind of job of creating a mold such as this, you would probably have one of these clamping holes in each corner just to help clamp the mold together. I've put an example in one corner here just so that we can get some experience of using the drilling operations within the CNC machining section of Creo. So this is the part that we're going to use as an example. You don't need to have the part open already in order to start a new machining assembly within Creo, but we'll leave this open in the background anyway. So in order to begin your machining assembly, you create a new file. It's a manufacturing type of file, and it's this first option here, so NC assembly. If you want to give it a specific name, so if we wanted to call it mold CNC, for example, that would be fine. We can type that there. And then depending on how your system is set up, you may then get the option of choosing the template type that you're going to use for your assembly. Some systems have this set by default to whatever is suitable. We want to use a metric system, so we want a millimeter newton seconds, NC absolute accuracy here. So that one, millimeters newton seconds, manufacturing, NC as in CNC, and our accuracy is going to be absolute accuracy. So okay, we drop into our new assembly. In many ways it's an assembly just like any other. It has the 3 datum planes and the datum axes that we're given when we create our assembly, and then we're going to run through some steps to actually set up our CNC assembly. So the first thing that we're going to do, very much like we did when we were creating the mold itself, we're going to assemble a reference model. So I'm going to click on reference model here, and then it will browse into my working directory, and in my case I want to bring in a file which is currently in session, so that is why I left that file open in the background. So currently in session, is it volume 1 or volume 2? So I have this preview open at the bottom of my file browser so I can see what I'm opening before I agree to it. Yeah, that is the half of the mold that I want to create my CNC machining to machine. And then very much in the same way that we assemble items in a normal assembly, we do the same thing with our reference model as well. We could choose the default location if we wanted, but let's just constrain this in a more manual way. So what I want to do, I want to take that datum plane at the bottom of my part. I want to make it coincident with that assembly datum plane there. So we've got that done. Let's say I pick this face on the end and make it coincident with that datum plane. Now it's defaulted to distance, but if I right click on that, I can change it to coincident. And then it's just got 1 degree of freedom left, so it's got this degree of freedom. And I think I'll put that datum plane coincident with that assembly datum plane. Again, it's defaulted to a distance constraint, but if I right click on the distance constraint, I can say I'd prefer a coincident. So there's my part, fully constrained. That's my reference model. The system at that point pops up this little warning saying it's adjusted the absolute accuracy. We just have to OK that message. We don't have to action anything particularly to do with that. So the next step, very much in common with the moulding assembly that we created, is to create a workpiece of material around our finished reference model. So workpiece, and then again, very much in the same way as the manufacturing assembly that we used to create the mould, we just supply some offsets to define the size of this workpiece material relative to the size of our finished part, or our reference model here. So we can do this in one of two ways. We can drag these little handles here, so you can see in -Z here I'm having an effect, and generally speaking, the way that we're going to create this this machined block is that we require extra material down below, so in -Z, in order to clamp onto with our machine vise that we're intending to hold this material in place with inside the CNC machine. So it would help if we have a little bit of extra material down below the part. So let's set this at 10 mil. Up above the part in +Z, we don't need much material, so let's set that as 3 mil. Maybe even 2 mil we could do. So the material above the part there will be machined away in one of our first operations. But the material, the excess there that we are going to machine away, just allows us to account for any inaccuracies in the shape of the block that we are provided with. So often when you're provided with a billet of metal, normally, it will have been cut on some kind of industrial saw often, and the saw blade can wander, it can produce non-parallel faces. So having this as an incredibly small value, so let's make it 0.2 of a millimeter, that can be quite dangerous in that if the person that's cut this block has done a bad job and the block wanders in and out and in and out, then that margin for error can be quickly used up. So let's put 3 mil back on there. The other offsets, let's have 3 on all of these as well, so I'm just entering these in these little boxes here. And then normally what I like to do is I just like to round my totals up to round numbers, because again, if you're requesting from either your materials supplier or the person within your company that creates these blocks relatively accurate measurements, so let's take this one, it has 3 decimal places, so it's down to microns. That is kind of nonsensical. So let's round these to at least round numbers. So let's have 51 here, and let's have 87 here, and let's have 198 here. So yeah, and that will adjust these offsets to account for that. But that kind of makes more sense. The block of material that you're going to request is going to be this size now. So we'll click on OK. There's our workpiece block represented in the same way as it is in the moulding setup, just as a transparent green block. You can see we've got our block of material, a coordinate system has been added in the center of our block of material in case we need that, and then our workpiece has been added as well. So the next step, it would be nice to put a representation of our vice jaws into this machining setup, and that can be useful, or that is useful for things such as collision checking. So often when the tools are being moved into position, there's the potential for them to impact or to collide with the fixtures that are holding the part in place, that are holding the block of material in place. So it can be useful to put a representation of any vices or other types of fixtures that are holding the part in place so that you can get an idea of that. So this is a extra part that we have to create before we can bring it in using the fixture button here. So what I'd previously done is just created a very simple representation of some vice jaws. So here's my representation of a vice. Again, this can be as complicated as you have time to model up. This is a very, very quick, just kind of rough U shape, just representing where the jaws themselves pop up from the main body of the vice. The only thing that I may have to adjust now is the width of the opening there doesn't quite match the width of my block as it's currently set. So what I'm going to do is I'm going to go into my assembly here, and I'm just going to get the analysis tool, measurement. I'm going to measure from this side of the block over to this side of the block. It's 87, so I need to make my vice jaws 87 before I bring it in. So this needs reducing down to 87, like that. And then I'm going to leave everything else as it is currently. So that's my vice. I've opened it in the background. If I go back to my assembly now and bring that vice in as a fixture, so I need to go back into my manufacturing tab. I momentarily came out into the analysis tab, but I need to drop back into the manufacturing tab now. So add a fixture, component, load a component in. So this is the load the component icon. I know that it's in session, but I can also spot it there within my working directory, so I'll open that up. And then it's just a case of positioning this in an appropriate position. So I'll bring it over here so we can see what's happening. So I'd like the kind of lower face of the vice there to butt up against the lower face of my workpiece there. So it's chosen angle offset. We've seen how to correct this. So if I right click over angle offset, I can make that coincident. And then I'm going to pick the jaw there, and I'm going to butt that up against the back face of my workpiece there. Again, it's chosen distance, but I can just right click on the distance and go coincident, like that. And then it only has 1 degree of freedom left, so it has the ability to slide this way. So I'm going to pick the plane that I've put running through the center of my vice and align it or make it coincident with that plane there. So don't want distance, I want coincident. So that's my vice fully constrained. So the jaws of that pop up and sort of overlap the bottom of my mold there. So I'm okay with that. So the next thing that we're going to do before we actually go on to create some milling sequences themselves is we're going to create a coordinate system for all our machining operations. So this is often referred to as the 0 point or the origin point, and all CNC machining requires the definition of where this 0 point will be, and this is essentially the point at which all measurements or all positions that the CNC head or the CNC table can move into are referenced back to. So this is the 0 on the x-axis and the 0 on the y-axis and the 0 on the z-axis. And there are numerous ways of setting these coordinate systems up, as in where do you locate them relative to the workpiece or relative to the finished machined part. The method that I like to use is to put it on one of the corners on the top surface of the workpiece of material itself. So this is a relatively easy position for a machinist to clock or to zero the machine onto. So I'm going to put it in this corner over here. So I'm going to say coordinate system, I'm going to zoom in a little bit and pick that vertex point there. And then if I go to the orientation tab, so I pick the point, so that's the location of the new coordinate system, but now I need to orient it. So I want Z to point upwards, away from this top surface of the block. So I'm going to say use, by clicking there, the top surface of the block, so I'm going to click on the top surface of the block, as Z, like that. And it will use the top surface of the block, and it will say, right, Z is pointing normal to that, or at 90 degrees to that. So I've got my Z direction, and then the system's automatically taken me down into the second entry box. That's why it's highlighted in green. And I'm going to pick this end face here. And it has chosen that as my Y direction. Now I want kind of left to right as I'm looking at it to be my X direction. So I'm going to change that to X. Yep, that's fine. But I want my X and Y positive directions to point into the block of material. So I'm going to flip the X direction there. And you can see now the Y is kind of pointing in towards the block, and so is the X. And the Z is pointing upwards. So that tends to be how I set my default coordinate system, or my origin point. So we've done that piece of the setup now. So the next thing I need to do is define a work center that I'm intending all of my cutting operations to be performed on. So what I suggest you do is either as you're doing this, you can pause and go and find a suitable work center. Seeing as this is a tutorial, we will kind of make up the parameters here. So maybe this is a mill center and it's made by Herco. The Herco range of mills tend to be named with a VMX and then some kind of number after them. So yeah, if you go away, do some research, do some reading, then you can fill in some of these properties. So something that we might want to fill in is what is the maximum extent that the head or the table can move in the Y direction. So maybe that's 1,000. What is the maximum that it can move in the X direction? Maybe this is 900. And what is the maximum that it can move in the Z direction? So these are the sorts of things that you might want to go away, research, and then you can fill in the specifics for your actual mill that you're intending to use. So maximum RPM, let's say 10,000. Horsepower you can fill in as well. I suggest you fill in as many of these as you can research and find. So let's say we're happy with our work center, so we have that set up, and at this point we can now define our operation. So the operation is kind of the higher level that all the milling or drilling or finishing sequences will be held within. So let's click on operation. There's two options really that need setting in here. One is the machining center that we're intending to use. So you can see, because we've already created that, it's been accepted, but we can have a list containing multiple machining centers here. So we can write programs from within Creo that are intended to be cut or intended to be run on multiple different machining centers, maybe with different attributes, different horsepower, different maximum RPMs, different extents of travel on the table. The second thing that we have to set is our operation 0 point or coordinate system. So that is what the system is waiting for me to select here. Now we did the work of creating this before we got to this point, so we can just click on it. There it is on the top corner of our reference block, our billet of material, if you like. So we'll click there, and that is really all we have to set. It can be useful at this point to set a clearance level, which is the level above which the machining center will move the tools in a rapid speed. So rapid speed is what it sounds like. It's a very quick speed that the machine moves the tools around when it is happy that they are clear of the block of material. So let's set that level here. Let's say that we're going to use a plane to set the level, and let's say the plane that we're going to create is going to be a set distance above the top of the block. So we can just click on the top of the block, and then we can set an offset above there. So let's set it at 15 millimeters, like that. And then see if there's any other parameters that we want to kind of modify. Seeing as we're in here, we have to tell the system that we already have a fixture that we've brought in. So here's our fixture, and we want to apply it to this particular operation. So I'm going to just select it, then it comes in, and then I can click on OK. So our operation's been set up. So everything that we've done up to this point, really, you can regard as the setup steps before you actually begin creating your CNC cutting actions. So let's create some milling sequences to remove some of the material from this block to hopefully create this mold shape eventually. So the two broad steps that we have to go through in order to create milling sequences is, first we have to mark out some manufacturing geometry. So this allows us to select areas or boundaries within the part that we want to then use our machining tools to remove. So let's create some manufacturing geometry first. Let's use the mill window option. So we'll click on mill window. We can see that the placement tab needs some input, so we'll have a look. So the window plane, in this instance, I'm just going to use the top surface of my reference model, or of my stock material, as it's referred to. So if I click on the top plane there, what the system does is it looks at the reference model, so the finished part shape that we need, and it essentially creates a boundary shape on that reference plane. You can see that boundary shape marked out here in orange. So if we look down from above, that boundary shape corresponds to the shape of the finished item that we want to machine. You can see that there's a circular section missing there because that hole passes through the entire part. So we've created a boundary, or we've created a mill window that we want to tackle. So we can click on OK there. So everything within that boundary is going to be marked for removal, for material removal in the next step. And then we've got all these various different types of cutting operations or milling operations that we can choose from. We can select one of them from up here in the menu, or if we know the manufacturing geometry that we want to use to create this milling operation, we can right click on that manufacturing geometry. So I'm going to right click on mill window, and the relevant types of milling sequences become available to us. So I'm going to do a face milling operation. So if I hover over this, that's a face milling operation. I'm going to use the mill window, so it's already accepted the mill window as my reference. I need to create a tool that I want to use for this operation, so I'm going to go in and edit tools. So I already have one tool in here, but normally when you come in here you'll have no tools like this, and that window will be shut. So in order to create a new tool, you need to enter some data about the tool, so the diameter of the shaft of the tool. Now, given that we're doing a facing operation, the diameter of facing tools tends to be quite large, so maybe I would put this up to 30 millimeters or 35 millimeters, let's say. And then I like to work like this. I like to see a preview of what the tool is going to look like with the given dimensions that I put in here. So I just like to go up to View menu and just click Auto Preview, switched on. So that is a 35 millimeter shaft when viewed from the side, 100 millimeters long. Almost all tools require some form of holder or chuck or collet to hold them in place, so I'm going to just create a very simple kind of holder to sit at the top of this tool like that. And it's important to put this information in because when the system looks for any collisions between the tool and the workpiece, any unintended contact between the two of them, it's important that you have a representation of the tool holder as well as the tool itself. And then I can put the cut-in height of the flutes on the tool. So if there's 100 millimeters of this tool sticking out, then a reasonable flute length might be 60 millimeters, something like that. So when I'm happy with that tool, I can click on Apply, it gets added to the tool table, and then I click on OK to accept the tool. And then at this point you may see on your system the tool path in orange marked out. So you can see this is where the tool begins, it travels down to the finished depth that it's going to cut out, and then it enters the part and cuts along here, and then it kind of hatches backwards and forwards across the part, and then it ends there. So if we want to see that sequence simulated, there are two main ways that we can do that. We can click up here, display the tool path in the graphics window. So if I just reposition things a little bit here so that we can see what's happening. So there's my tool, and then I'm going to slow this sequence right down when I play it because it's often very quick and you can't really see what's happening. And then I'm going to click on play, and you can see it kind of drops to the finished machined level, and it kind of passes backwards and forwards, removing material as it goes. So that's a good way to preview the tool path relative to the part. And we can see here, because this is a face mill, the face mill operation will cut material away inside our mill window boundary, but it will only go so deep until it reaches some geometry from the finished part. So it's cut down to this face here. So the first surface or the first face that it encounters, it will stop at that depth. That's what the face mill does. It's intended to allow you to remove relatively large amounts of material down to the actual geometry of the finished part itself. So that's our face mill. There is, however, another option for visualizing this milling operation. So if I close this play path option down, and then if we click on the drop down menu at the side of the button that we just pressed, this option at the bottom gives us an approximation of the actual cutting of the stock material itself. So display the cutting tool motion as it actually removes material from the workpiece. So if we click on there, we drop into a slightly different mode, and then we have to click that icon in order to start this simulation. That's not always immediately obvious, but if we click on that icon, we get broadly the same kind of play and rewind controls that we had before. So if I slow the speed right down again and press play, we can see that the system now simulates the removal of the material itself. So if we go back to the start there and then play again, you can see that the material actually was removed from the block. Another useful tool that we have in this particular mode when we're simulating with stock removal is we can use the compare tab, and then we click on compare to compare or to see how far away we currently are from our finished geometry that we intend to create. So the way to read this is that the majority of the block is marked in blue here, so the blue colour, the deep blue, means that the majority of the block is more, or is 1 millimeter or more away from its finished shape. But these two little kind of island shapes here are within 1/4 of a millimeter of their finished size. And we can edit these values here, so if we want a kind of more accurate assessment of how close we are, we can put this range in even tighter, so we can tighten up this tolerance and then we can compare again. So these, essentially these two faces are at their finished size. They're within a 0.2 tolerance of their finished size. So it's quite a useful tool, this, to see how much more work you have left to do with your milling operations in order to achieve your finished shape that you're trying to achieve. So let's close the simulation down, and we'll OK this first face milling sequence. So that's our first sequence created. So with my next milling sequence, I'd like to do something similar. I'd like to use my big face milling tool that I've already created, but I'd like to, what I'm going to do just before I start describing the sequences, I'm just going to temporarily hide my block of material there. So my stock material block was obscuring my ability to actually click on my reference model, so I've hidden the workpiece temporarily. So what I'd like to do, I'd like to use my face milling tool, but this time I'm not going to create a face milling operation. I'm going to use a roughing operation, but I'd like to direct the tool to this surface here. So this blue surface that I've just selected, so now it's highlighted in green, I'd like to machine all the way down onto that surface, both here and over at this side as well. So I'd like to take the level of the top of the block down to that level, and then obviously I want to leave these two kind of island areas that stick up alone. So what I'm going to do, I'm going to do something similar to what I did before. I'm going to use the mill window to create my manufacturing geometry. I'm now going to set the window plane down on that surface that I want to machine down to. The system marks out again the kind of perimeter shape of my material, and then the one extra thing that I'm going to set this time that I didn't set last time is the depth. So the face mill automatically stopped itself at the depth when it hit its first piece of geometry. Because I'm using the roughing sequence type this time, I'm going to actually set the depth that I want it to stop at. So specify depth. I don't just want to use a blind value, I want to say to a selected feature or surface, and the surface that I'm going to select is this surface here. It could be this one, they're at the same level, or it could be this one. I'm going to select that one there. I'm happy with my mill window now, so I'm okaying it. You can see I have my mill window 2 there. And then this time, with the mill window selected, I'm gonna click on the roughing tool up here. As I already said before, you can right click on the manufacturing geometry and then select it from this menu, or you can pre-select it and click on the icon up here. Doesn't really matter. I only have one tool in my tool table and it's defaulted to that tool. If I wanted to create a new tool, I could go in there and edit tools and create a different type of tool. But for this particular roughing sequence, I want to use the same quite large 35mm tool. And then one thing that we didn't do before was edit any of the cutting parameters for this particular sequence. So if we have a quick look at some of the options that are available here in the parameters tab, The key ones are going to be the feed. So this is the speed that the tool will move in X and Y. So as it's cutting material away, how quickly is it moving? So we can edit these values here. So maybe we decide that this is a little bit fast, and we drop that down, say to 600. And the other key one is the spindle speed. So this is the rotational speed that the tool is being spun at. So again, maybe we want to edit these manually. There's a lot of other options in here, such as how deep a step do we want to take material from, and we'll come back in and kind of modify these and see their effect in a second. So let's say we're happy with that and we want to view the toolpath. So the tool is dropping down, it's kind of cutting in one direction. Has it dropped to the finished level? Yes, it appears to. So it's down on these blue surfaces here. It's cutting material all the way down onto there. So let's speed it up a little bit. There it is. And we can see it avoiding these two island shapes here. So again, if we want to see the actual stock being removed, we can click on stock removal. The slight problem here is, because we've already removed some stock in the previous milling operation, in order to see the block of material represented after the first face mill, we have to OK our current sequence, and we have to go all the way back up to our operation level that we created here, and then we have to run our stock removal from there. So the way that we do that is if we right click at the operation level. So as I said when we were setting this up, the operation that we created is a higher level hierarchically than all the manufacturing geometry and milling operations that we're creating. So if we right click there, we can simulate the stock removal. You can see the stock removal simulation icon there. The only slight problem is currently we have the reference model hidden. So you can see the reference model is not showing up in this material removal simulation. So in order to correct that, I have to right click on that model and show so that it becomes visible again. And now I can click on operation and simulate stock removal, and I can perform the face mill and the roughing consecutively. So click on simulate, maybe turn the speed down a little bit, play. So that's our face removal that played first there, and this is our roughing that we're seeing now. So here's the roughing operation. It's avoiding the islands, roughing out the stock. Almost complete, and then when it is complete, we can do a compare again. So if we run the compare tool, and you can see now we essentially have finished the surface on the top of the mold as well. So before, when we looked at this, we just finished the surface on the top of the islands. Now we finished all the way down to finished geometry size on these top surfaces as well. But the slight air vents aren't showing up in this preview, and that's because this range that we're looking at in green is too wide at the moment. So maybe we can reduce this down to 0.05 plus and minus, and then compare again. I think maybe that's a little bit tight, so let's play with this value a little bit. So there's only so much accuracy that this, there we go. So if we tighten in the range that the green colour represents, So now we have a range of 0.2, so we have minus 0.1 plus 0.1. We can see that the grooves that are still to be addressed there are showing up. So we still must do some milling operations to actually remove the material in the grooves. But that's okay. We will address that later on. So next we're going to look at a slightly different type of creating manufacturing geometry. So we've used the mill window that looks down from above onto the part and kind of marks out a boundary, sometimes to a given depth. Now we're going to look at mill volume and how you set up mill volumes to mark out your manufacturing geometry. So if we initiate a mill volume, some of the tools in here you should be familiar with, so the extrude tool we've used, the revolve tool, other solid feature type tools, the sweep, the swept blend, rotational blend. These are the sorts of tools that you have access to when you're part modeling, so we should be relatively familiar. And what I'm going to do, I'm going to create an extruded shape, so I'm going to click on extrude. I'm going to go into the placement tab. Just like when we create a normal extrude, it's waiting for me to either create a sketch to create the extrude from, or to select an existing sketch. So I'm going to say I want to define a new sketch kind of from within this tool, so define. It's asking me what plane I want to sketch on. In this case I'm going to sketch on the end face of my reference model, so here. Then it's asking me for a reference plane or reference edge to define which way up I want to view this sketch. So I'm going to select the top plane of the assembly there, so you can see where that is in my assembly, so click on there, and I'm going to say the orientation is that that should be at the bottom, so bottom, and then I'm going to sketch. Now it's picked the wrong side of that plane, so I'm just going to quickly go into sketch setup and change that to top. That's better. It doesn't really matter, but yeah, it's nice to keep the thing the correct way up. So now I'm going to sketch, and all I'm going to do, if I kind of rotate my view off angle slightly, I'm just going to project a copy of this set of edges, so this kind of trough shape that we have in our mold. So I'm going to use the project tool. I'm just going to leave it set to single lines, and I'm just going to click on these edges just to bring a copy of them into my sketch. And then to create a closed boundary, I'm going to use the line tool and just close that boundary in, and then middle button to cancel the line tool. So that's the shape that I'm going to use to create my extruded volume. So I'll click on OK. Then I have to give this thing a depth. So I could give it a blind depth. It's going in the wrong direction at the moment. I want it to go in this direction. I could give it a blind depth, but because of the shape that I'm trying to machine, specifically this kind of curved shape of the handle, at some point this extruded shape intersects or interferes with the finished shape of my part. You can see there's kind of overlap there, or interference. So it's probably safer, rather than giving it a blind value here, I'm going to change that to up to selected, and I'm going to extrude up to, let's say, that face there. So I can be pretty confident with my design that my extruded shape now won't interfere with the actual finished shape of the block. You can see that it's got some space between the two. So I'm going to click on OK. There's my volume that I've created, my mill volume, so I'm happy with that. So I'll click on tick. There it is, represented in the machining display. It's not that useful to have it permanently displayed like that. Now that I've created it, there's nothing wrong with hiding it in the graphics display area. It just Makes it difficult to click on other things if you have lots of these mill volumes visible. So I'm going to right click on it and hide, but you can see it's still there in my model tree. So now I'm going to use that as the basis for a roughing pass. But just before I do, what I'm going to have a look at is what radius of curvature these edges are that I've designed. So in analysis and in measurement, if I click on those, so their diameter is 13.13. So that might be reasonably useful to know. So back into mill and roughing, or let's do a volume rough. So we're going to use this mill volume and we're going to create a volume rough. So we can do that down here in the quick access menu. There's volume rough. It's defaulted to use the large first tool that we created, T1, which was a flat end facing tool. So that's not really a suitable tool for this operation. So I'm going to go in and say edit tools with the intention of creating a more suitable tool. So I click here on the new tool file icon. So click. Now I get to create my second tool. I don't want a flat end mill. I probably want either a ball end. So that's what a ball end mill looks like. It has a hemisphere on the end of it, or possibly a bull mill, which is a combination of an end mill that has a flat surface on the end and a ball mill with a radius on the shoulder there. So let's try one of these. Let's have this at let's try 15 millimeters to begin with, and let's have a radius in the corners of this of, let's try 5. So you can see our preview updating here, preview of the tool. That's broadly speaking what it'll look like. Let's put a collet or a holder on this for the tool as well. So there's our holder. Yeah, let's say we're broadly happy with that. Again, to add a little bit more detail here, we can actually set the cutting data for this tool from within the tool setup itself. So previously we looked at the cutting data within the milling operation, which you can set the cutting data there, but you can also set the cutting data inside each tool. However, when you use the same tool but for different operations, sometimes you want to modify slightly the standard tool cutting data. So let's say the RPM here, we're going to spin this at 3,300. Let's say we're going to have speed at 500 for this, and all the various other options we can set from within the tool setup menu itself. So let's apply that. It gets entered into our tool table as tool 2. We'll click on OK to use it, and then we want to simulate what these cuts will look like. So we can click on the simulate tab here, and then we can play this simulation. So yeah, it's kind of swoops in here. It takes various levels of cut. It was a little bit quick to see that, so if I slow it down and go back to the start, yeah, so it's working its way down. It would be nice to see what the block of stock material looks like after this operation is complete. So in order to do that, I have to close this simulation down, OK the volume mill sequence, so OK that. You can see the toolpath there displayed. If you just want to view the toolpaths from this top level, when you're not in a sequence, you're not editing a sequence, you can right click on the sequence and the toolpath becomes visible, or you can turn that ability on and off by clicking on that icon there. So that makes the toolpath visible if it has actually been calculated at that point. So I want to run all three of these milling sequences one after the other. So there's our first one, there's our second one, there's our third one. If you want to simulate all of them, you go up to the top level here, operation 10 on our Herco, and you run the stock removal simulation, which is there. But as we saw before, in order to make that stock removal simulation work, we have to make our workpiece visible again. So we've had it in hidden mode just to make it easier to select geometry from our reference model. So you have to make it visible, and then we can go to our overall operation, click on stock removal or material removal simulation, and then click on this icon to allow us to play this. One option in here that it is quite useful to set is this option here in the view menu, stop at sequence. What that allows us to do, if we select that, so just check that it's on, yes it is on. When our first sequence gets machined away, or when the stock gets machined away from the first sequence, the simulation will pause. So that can allow us to maybe use our compare command at that point to see what material we've removed, any areas that are at their finished size, anything that we want to kind of analyze about the part. And then we can press play again, and it will move on with our second milling sequence, and then it will pause again after that one is complete. And then if we press play a third time, then we can run our third milling sequence. So it's more useful arguably than having that unselected where all sequences get played automatically, and it can be difficult to see what each sequence is achieving. So let's click on play here. Did the face mill happen there? Let's check. No, it hasn't happened, so I didn't click on play. Let's click on play. There's the face mill. How do we know that it's the face mill? Well, if we check the compare, yep, we can see it's taken a slice of material off the top down to those two islands that we had on our part. Then we have our roughing steps that machine down to the next level in the part. Again, if we want to compare the finished part with what we've achieved there, we can see that we're down at finished geometry more or less on all these green areas, but we still have a lot of material to remove from the center here. So then we'll run our little sequence over here. So let's see how close we are to the finished part. Relatively close. So the green areas are getting relatively close to their finished kind of size. One thing that it probably is worth addressing at this point is, because of our part design, we would be happy for this tool to move further to the left here. So it's left a wall of material there that we really would prefer to be removed. So in order to achieve that in this instance, if we kind of come out of this simulation, if we go back into our extruded volume, so there's our extruded volume, and we go edit definition, what we could do very simply is just say from our sketch we extruded to this depth in this direction. Well, we could extrude in a second direction, and we could extrude up to the outside surface of our workpiece like that. So there's our sketch in the middle. We initially extruded over there. We've now said we want to extrude in the opposite direction by a certain amount. So if we click on OK now, and then try simulating all our steps again, let's see what we achieve. So I'm going to leave the stop at sequence switched off this time, because I just want to run through very quickly to the end of this whole set of machining sequences. So yeah, that's slightly better. In actual fact, it wouldn't hurt anything if we extended that extrude even further. So maybe if we extruded it out by a set amount, not too selected, by a blind value, yeah, well, we could do the calculation and figure out, but let's just set it at 16 for the time being. So that will now cause our volume mill to extend well past the outside of the part. So I'm just trying to get a preview of the toolpath. So there's the toolpath. So it's going well outside of our workpiece now. So it should break through. And if we wanted to simulate that, we could come back out and say simulate stock removal, play, maybe speed this right up. Yeah, that's arguably better for our purposes in this particular part. So you can see that trough shape, we're broadly speaking within a reasonable tolerance of the finished shape of that slot. So we've used the volume mill or mill volume type of manufacturing geometry to achieve that, and the volume milling sequence type as well.